Just give me a second, sir.
Okay. Integrations. So you know that the differentiations, okay, you can just write within bracket the reverse differentiation. Okay. Reverse differentiation. Right. We know how to differentiate y is equal to, say, x squared. So what is the differentiation of y is equal to x squared? dy by dx is equal to 2x. Is it okay?
Yeah.
dy by dx is equal to 2x. Right. So I have mentioned here that integration means the reverse differentiations. Integration means the reverse differentiations.
So you're going basically 2x into x squared like that?
No, if you differentiate x squared, you get 2x. So if you integrate 2x,
You get x squared like that.
we get x squared. I mean, if the forward is differentiation, then the backward is integrations. So
Yeah.
you can see that the symbol there, it's the way we just write it, the command to integrate. Integrate, this is the command, okay, just like a hook shape. With respect to x, dx is equal to x squared. But we have an option, we have a problem here. It's like this. Just tell me, what is the differentiation of x squared plus 1?
X squared plus 1 is 2x.
It's 2x. Right. What is the differentiation of x squared minus 1?
Is also 2x.
Also 2x. So x squared plus 100?
Also 2x.
Also 2x. So x squared plus, say, minus 1000, it's also 2x. I said that integrations mean the reverse differentiations, but you can see that we have so many options, infinitely many options to differentiate and then get us 2x, the answer.
Yeah.
The answer is 2x. But here, the thing is, if you differentiate x squared plus 1, you get 2x. So integration of 2x is what? X squared plus 1. Right? And if you differentiate x squared minus 1, you get 2x. Integration of 2x is x squared minus 1. We have here so many options, right? Many options. So if you integrate 2x, you can still keep writing it here. You can just keep writing it further. So because we have infinitely many options here, x squared plus something. So what we are going to get for the integration of 2x out of this list here, which one you're going to get?
All of them.
All of them is possible. So you should write the general way of it, which is x squared plus a constant. You see that? X squared plus a constant. This C is called arbitrary constant. Okay. Arbitrary constant. Okay. So remember, these kind of integrations are called indefinite integrals. What is that? Let me just talk about that one. Indefinite integrals. What does that mean? It means that, like you see here, if the values are not defined, there's an option that the values will be defined here sometime. Say, for an example, have to integrate 2x from 1 to 2, which means the values are defined here, right? Some values are there next to the integral sign. There are some values. So if okay, then we call it as a definite integral. If the values are defined, it's definite integrals. If the values are not defined, it's indefinite integrals. Understood what I'm saying? So here, the values are not defined, right? Correct?
So it's indefinite.
Indefinite. Agree with it?
Yeah.
Okay. So if there's an indefinite integral, always there will be a C. In the final answer, you will always have a C.
Okay.
Right. Now, so we have a rule to differentiate it, right? This is the rule to differentiate a function, x to the power n. dy by dx is equal to n x to the power n minus 1. All right?
Yeah.
Right. So this is to differentiate it, but there's a similar rule to integrate it. So integration of x to the power n, okay, will be equal to x to the power n plus 1 divided by n plus 1. It's an indefinite integral, so plus. So this is the rule to integrate.
Okay.
So the rule says that you have to add 1 to its power and then divide by the same power.
Yeah.
For an example, say you have to integrate x to the power half. Okay. So integration will be x to the power half plus 1 divided by half plus 1 plus c.
Yeah.
X to the power half plus 1 is x to the power 3 over 2. Divide by 3 over 2. You can see that. This 3, you can see that if this 3 can be brought up, right, to the numerator. It's 2x to the power 3 over 2 over 3 plus c. Or you can just imagine as it's 1 over 3 over 2. It's a reciprocal of 3 over 2, which is simply 2 over 3. Understood?
Yeah. Wait 1 second.
Any questions up to that?
No.
No, sir.
Okay.
Let me just write this down.
Yeah, I'll give time to copy it. Let me just explain all the theory parts. So we'll give
Okay.
time for you to copy all of them together. So this is one case, I mean, just explain it. And then all the rules you followed must be followed here. I mean, all the rules you followed in differentiation must also be followed here, which is like you can't have an x in the denominator. Okay. So
Yeah.
example, say you have something like this. 1 over x. First of all, you have to bring it up. Correct?
Yeah.
Can't have an x in the denominator before integrating it. So now we'll apply the rule. So what we are going to get? -1 plus 1, right? What is it? 0. It's divided by 0 then. So do you think that this is possible?
Wait, I don't get it.
Like you just add 1 to its power and then divide by the same thing. So -1 plus 1 is 0.
Yeah.
So 0 divided by x to the power 0 over 0.
That's just 0 then.
So no,
So
it's not 0. We can't divide a value
okay.
by 0. It's undefined. So for you in P1, 9709, you won't get this. You won't get something like this because it has a different integrations, which is ln x. Okay, that you're going to learn in second year.
Okay.
Understand what I'm saying?
Yeah.
So you don't have to worry about it. Any questions after that?
No.
No.
Right. But you may get something like this. You see here, 1 over x to the power minus half. Sorry, I'll just go with -3 over 2. So what are you going to get? This is, when you bring it up, it's x to the power plus 3 over 2. And then apply the rule, x to the power 5 over 2 or 5 over 2. That 2 can be written over here. Because 3 over 2 plus 1 is 5 over 2. 5 over 2 divided by 5 over 2, I just bring the 2 up straight away and then wrote the straight answer. Okay. Is it okay?
Yeah. Yeah.
So this is the main rule we use to integrate it. Right. So here we have to know a couple of stuffs. First of all, tell me, what is the differentiation of 2x?
Differentiation of 2x is just 2.
2. Differentiation of 5x is 5. Differentiation of 10x is 10. So integration of 2 is what?
Integration of 2 is going to be 2x plus c. Yeah.
Because you see, I have mentioned some important
Yeah.
that Integration means the reverse differentiations, which means if you integrate it to get an answer, if you differentiate the answer, you should get the question.
Yeah.
You can just differentiate and check it, because if you are familiar with the differentiation, this one is easy. You just differentiate 2x plus a, it's just 2. So you have the question. So your answer is fine. You can self-verify it.
Yeah.
Okay, right. So integration of anything is fine now. Agree with it so far?
Yeah.
This is just a basic integration. Right. Now we'll talk about the applications of integrations. Right heading? Applications of integrations. Okay. Applications of integrations. Applications of integrations. Okay. The main application is to find the area and the volume. I'll give time to copy, okay? Look at this carefully. Area and volume. Right. Imagine you have a curve like this. Imagine you have a curve like this. Something like this. Say just y equals f of x curve. And you're supposed to find the area, say from A to B. I mean this area. We know few equations for the regular shapes. If it's the rectangle, we know that the length into width. If it's a triangle, half into base into the perpendicular height. Trapeziums, half a plus b times h. Right? Each and every regular shapes, there's a formula.
Yeah.
But this is not a regular shapes. Do you see that? We can't just name this. You see here, because this portion is not a straight line. Okay. If it's a straight line, we can say this is a trapezium, but it is not. It's a curved part, right? So it's an irregular shapes. Agree with it?
Yeah.
So how do I find the area of this? The area of that one is given by integration of y dx. Okay. I mean, we just integrate the curve with respect to x. From where do I have to find the area? From A to B. So you just put the values over here, A and B.
Does not matter or like for example, you can put A on top and B at the bottom, right?
No. From left to right, I think it's a ideal options to do it from left to right.
Okay, left to right is like bottom to top. Okay.
Yeah. Otherwise, you can still put it, but just fine. I mean, it's from B on A on top and then B in the bottom. You will get a negative answer then.
Okay.
Exact answer, but if you get plus 15 for this one, you will get negative 15 for that one if you just switch the order.
Okay.
Okay. Right. But because the area must be positive here. Okay. So this is the equation we use to find the area. Let me tell you something important. Then you can do any questions. You will get an answer for this one, right? I'll just talk about the way we calculate it. We will get an answer for this. Okay. The answer we get for this one will be the area between the curve. This is important. Between the curve and the x-axis. That's very important. Always it's between the answer you get for this one, okay, will always be the area okay, between the curve and the x-axis. It's the
Yeah.
area, okay? It's the area between the curve and the x-axis. I'll write it here, area between the curve and the x-axis. That's very important. Get it?
Yeah.
If you have something like this, say you have a graph like this and another graph looks like this. Okay. And then you're supposed to find this area. Do you see that the problem here?
Yeah.
So if that's the case, say the one in red color, let me name that as a y1 curve, and the one in green is the y2 curve. Say this point is somewhere between A to B. Okay. If you integrate curve 1 with respect to dx from A to B, you will get the area under the curve and the x-axis. I mean, this whole area is what you're going to get.
Yeah.
Correct? You're going to get this whole area. Any questions?
No.
Right. But we need to find the area, this which is shaded, right?
Yeah.
To find that, all what we have to do is we find the area under the curve y2 from where to where? A to B
And then minus the both values.
minus them. So you'll get the remaining area, just like the usual things, but we are just dealing with the integration stuffs.
Yeah.
Understand what I'm saying?
Yeah.
Okay. Abdul, how about you?
Yeah.
Okay. Right. Could you please take a note of this after this?
Yeah.